So to work a couple of examples approaching conic sections with the eccentricity and directrix, kind of that way. We want to find the equation of the ellipse. We want to sketch a graph of the ellipse, and we want to label or be able to list the ordered pairs for everything that's important, all the important points. So with an ellipse, we're talking about equations of the vertices, not equations, but coordinates of the vertices, coordinates of the foci, and equations for the directrices. So if we start with the information that we're given here, we know to begin with that A is 9 and E is 1/4. So if I think about starting to sketch what I can about this ellipse, I'll tell you what, I'm going to be actually accurate this time with my sketch. So let me grab some graph paper. Okay. I have a vertex at 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be here. And another vertex at 0, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So I'll call that V1 and V2. It really doesn't matter which one you think of as the first one and which one you think of as the second one. 0, negative 9. Okay. Alright, if we know A and E, thinking back to the information that I gave you kind of at the bottom of that chart, I can find the value of C, because C is always equal to A times E. So C in this case would be 9 times 1/4, or 9/4. Remember what that tells you. That tells you the coordinates of the foci. So we're going to have a focus at 0, 9/4. Say 9/4 is 2 1/4, so that would be about right there. We'll call that F1. So that's 0, 9/4. And we'll have another one at 0, negative 9/4. D is always equal to A divided by E. So in this case, where A is 9 and E is 1/4, we get a value for D that's equal to 36. Now what that's going to do is that gives us the equations for the directrixes. Now since we've got vertices and foci that are on the y-axis, then our directrix lines are going to be horizontal. They're going to cross the y-axis. And the equations for those would be y is equal to positive and negative 36. Now I don't have room to put those lines on my graph, but you just need to make note that that's what they are. Alright, to be able to finish this then, we need a value for B so that we can know how wide our ellipse is and get a good sketch, and also so we can write the equation for it. So this is an ellipse, so B squared is equal to A squared minus C squared. B is what I don't know. A squared would be 81. C squared would be 81/16. So B is going to be not a very pretty number. 1,215/16. So B is approximately, B would be the square root of that. We'll need this number for our equation. To be able to plot that point, I need to know that B is approximately 8.7. So 1, 2, 3, 4, 5, 6, 7, 8.7 0.7 would be about right there. 1, 2, 3, 4, 6, 7, 8. 0.7 would be about right there. So we've got an ellipse here that's almost as wide as it is tall. This ellipse is very, very non-ellipsy looking. It's almost looking like a circle. And I'm actually terrified to try to sketch this curve, but I'll do the best I can. Oh, not so perfect. Yes, this part not very good at all. Let me try that again. Okay. You'll do a better job on your paper because you actually can erase and move your paper around to make it easier. So there's our sketch, sad though it is. The equation then would be x squared over a squared plus y squared over b squared, and we're going to have to do something a little creative here in just a second, equals 1. Now, you don't want to leave your equation like that. You want to invert that fraction and multiply. So change that to x squared over 81 plus 16 y squared over 1215 equals 1. Okay, that's actually not right, that equation. All right, x squared ought to be over b squared, 1215 over 16, and y squared should be over a squared. So 16x squared over 1215 plus y squared over 81 equals 1 should be the correct equation. That's right. Okay, same directions, new example. This time we're looking for a hyperbola, working with a hyperbola. The vertices for the hyperbola are 0 and positive and 0, positive and negative 4. Eccentricity is the number 2. Okay, so we've got another vertical major axis to deal with. And, alright, I'll make this drawing accurate as well, since I can. So what we know so far is the point 0, 4 and the point 0, negative 4. Those are the vertices of my hyperbola, which tells me that the value of A is 4. The value of E is 2. So C, which is A times E, would be equal to 8. So I'm going to have a focus. Your foci were going to be at 0 and plus or minus 8. So that would be there. And there. So we're going to have a vertex and vertex. Label those points. Alright, directrix lines. D is equal to A divided by E. So if you take 4 and divide by 2, you get D is equal to 2. So we're going to have a horizontal line at y equal 2 and a horizontal line at y equal negative 2. So those are going to be the directrix lines. Oops. So I'm going to draw those real quick. Y equals 2, y equals negative 2. There's the two directrixes. Okay, we need B. This is an hyperbola, so b squared is equal to c squared minus a squared. C squared would be 64. A squared would be 16. So that gives us a value of 48 for b squared. And we just need the value of b so we know how wide our box is. That's about 6.9. So 1, 2, 3, 4, 5, 6, almost 7. 1, 2, 3, 4, 5, 6, almost 7. And our box then has to go through each vertex. Oops, that's a little long. I'll fix it in a minute. Alright, so asymptote, asymptote, stretch them out. Oops, kind of run out of space there. Okay, so I can sketch my hyperbola. It's going to go through the vertex and use the asymptotes as guidelines. So the equation for this hyperbola is going to start with y squared over a squared minus x squared over b squared equals 1. Let's see. We might need equations for the asymptotes here. Those asymptotes lines are going to have equations y is equal to plus or minus 4 over a yucky number. 4 over the square root of 48, and you can simplify that square root if you want to. That's a 48 right there times x. Alright, so there's that example.